Section 05 is adding probabilities. Notice I got a little or out to the side. So that's kind of what adding probability is. You want this or this to happen. And we'll go through there. I guess first of all, we should start with what is probability. Probability is the measure of how likely an event is to occur. And probability can range from 0. So 0 or 0%. That means the probability of the event happening is 0, means there's no way it's going to happen. Okay, not going to happen. Like us going back to school this school year. Probability 0. It's not going to happen. And then it ranges all the way up to a probability of 1 or 100%. And that's guaranteed to happen. Absolutely will happen. Okay? Right in the middle is 50% probability. You can write them as a decimal or a percent. Sometimes people write them as a fraction. But we want decimal or percent. All right? So, first thing, so that's probability. There's two types of probability we're going to deal with. All right? The first type is what we call theoretical probability. I think I spelled that right. I'm sure somebody will tell me if I didn't. Okay. I know you guys have heard people say, like, in theory, this should happen, or blah, blah, in theory, but it should happen 50% of the time. That means, like, in a perfect situation. Okay. In a perfect situation, like, it should happen. That's like absence of anything going on. Okay. So that's when you hear people say, in theory. Okay. And what that means is an ideal or in a perfect world, if you will. All right. That's when all outcomes are equal. Remember, outcome is what happens in a single event. Okay. In theory. So in theory, if I flip a head, flip a head, cut off a head, flip it. No, flip a coin that it should come up heads, then tails, and heads, then tails. That's in theory, but that's not how it works. We know that. Okay, so that's what theoretical probability is. And to find theoretical probability, all right, probability of the event happening, that's what this P of E means, equals the number of favorable outcomes divided by the number of possible outcomes. Okay? In other words, rolling a die, a single die, 1, 2, 3, 4, 5, 6. There's 6 possible outcomes. If I wanted the probability of rolling a 1, well, there's one favorable outcome. One side of the die is a 1, 1 out of 6. Okay? We'll do examples. Don't worry, guys. I'm not going to just leave you hanging. And then the other type of probability is what we call experimental probability. And experimental probability comes from actually when you use the outcomes from an actual trial. Not like guilty or not guilty, like doing trials. Like, yeah, no. From an actual trial or experiment. So if you were to roll that die 50 times and record everything that happens, you might find out that the experimental probability of rolling a 1 is not 1 out of 6, okay, or 1/6. You might get a lot of 1s, you might get none. It's possible. That's experimental probability. And you actually use like raw data to get that. The probability of an event happening there is pretty much the same thing, just different wording. It's the number of favorable trials, because you actually did the experiment, over the total number of trials. Basically, guys, think of probability as this. What you want to happen over what can happen. Okay? What you want to happen over what can happen. That's what probability is. All right, now, there's two types of probability we're going to deal with when we deal with adding probabilities. All right? The first thing is called mutually exclusive. Okay? Mutually exclusive events. All right? Mutually exclusive events are events or things, be fancy, that cannot happen at the same time. Those are what we call mutually exclusive events. Okay, they mutually exclude each other from happening at the same time. And to do that probability, all right, so if we want the probability of A or B happening, it's very simply the probability of A plus the probability of B. All right, Miss Friends, I don't get that. What do you mean by mutually exclusive? I've never heard that before. So in other words, let's take that same die. And you know what? If I had a die laying around, it would work. So hold on a minute. And he's back with two dice or one die. Okay, so mutually exclusive. Okay, they cannot happen at the same time. It's impossible. For instance, if I wanted to say what is the probability that I can roll a 2 or a 6 on this die, okay? There's no way that I can roll a 2 and a 6 at the same time. It's impossible. That's why it's called mutually exclusive, okay? It cannot happen at the same time. So if they are mutually exclusive events, all I do is take the probability of one of the things happening, add it to the probability of the second thing happening. So the probability that I can roll a 2, well, how many are favorable outcomes? Well, there's 1. There's 1, 2. There's 1, 2 on the die. Okay? So the favorable is 1. All right? And then there are 6 sides or 6 different numbers. So I have a 1/6 probability of rolling this 2. And then I have the same probability for rolling the 6. So 1/6 plus 1/6 is 2/6 or 1/3. So I have 1/3 probability of rolling either a 2 or a 6 when I roll that die. Okay? So in theory, if I rolled it 3 times, I should get one of those. Well, look at there. It's like magic. It's a 2. Yeah. Anyway, so that's mutually exclusive events. They cannot happen at the same time. So what you do is you find the probability of one, add it to the probability of the other. That's your total. Now again, we're only doing one thing. We're rolling the die one time. We want either a 2 or a 6. That's all we're looking for on these. We're doing one trial. Okay? That's it. All right, let's move on. Okay, so let's look at another problem. Probability of getting a king or a queen in a standard deck of cards. Now I have a standard deck of cards here. That's what a queen looks like. That's what a queen looks like for those of you that are not, I can't even speak, who are not familiar with that. Okay, there's 52 cards in the deck. Blah, 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 blah. Now, I did post this little guy right here because I don't know how many times I get the people say, I don't know how many cards are in the deck. I don't know anything about them. Well, so I gave this to you. 52 cards, 4 of each shoot. That's 13 diamonds, clubs, hearts, spades. Ace is like a 1 through a 10, and then you have a jack, queen, and king. Okay, so this is on eCampus under this lesson, or under this week somewhere. So, yeah. So, if I want the probability of getting a king or a queen, well, they are mutually exclusive. Okay, and if I look right here, okay, see? Kings, 1, 2, 3, 4. Queens, 1, 2, 3, 4. So there's 4 kings, there's 4 queens. Okay, so these are mutually exclusive. So it's going to be the probability of the king. I'm going to abbreviate here, plus the probability of the queen. Well, I just showed you. There's 4 kings. See? Right here. 1, 2, 3, 4. I know. I can't see it, Mr. French. Well, you can see it if you look on eCampus. So, yeah. So, it's 4 out of 52. There's 4 queens. 4 out of 52. That's 8 out of 52. Which, if you do the math, divide by 4, that's 2/13. Okay? So, you have 2/13 probability. Okay? And you can divide that or whatever. Most time like that, you leave your answer as a fraction. Okay? Those are mutually exclusive events. They cannot happen at the same time. Now, then we have not mutually exclusive. Okay? Not mutually exclusive. Okay? Not mutually exclusive events. Okay? That means that 2 events can happen at the same time. All right? Now, what do I mean by that? Well, first of all, let me give you the little formula for that. So, the probability of 2 not mutually exclusive events means they can happen at the same time. So, it's still the same thing. The probability of A or B happening is the probability of A plus the probability of B, just like the other one, except you have to subtract the probability of A and B happening together. So let me give you an example of that. Okay, I'll give you a couple examples of that. Let's look at the probability. Let's take our little die back. Come on, buddy, you're back. Okay, and we want to know what's the probability that I can roll a 2 or an even number. Okay, so those are not mutually exclusive events because I can get a 2 and an even number at the same time. How? Well, where are you, 2? 2. That's 2. That's also even. So what this would be is the probability of a 2 plus the probability of an even number minus the probability of, whoops, I forgot my P, of a 2 and an even, which would be a 2. If it's a 2, it's also an even. So probability that I'll get a 2, well, there's 1 2 out of 6 sides, so that's 1/6. Even numbers, well, there's the 2, 4, and 6, so there's 3 even numbers. But then there's one that's both even and 2. That's like a union is what that is. It's the union of 2 and even. It's 2 and even. Okay? So you can't, that's not really a good choice. But anyways, we'll go with it. So it's 2 and even. There's one of those. So subtract that. Do the math. You end up with just 3/6, which is 1/2. So there's a 50% chance, 50% probability that when you roll this die, you're going to get a 2 or an even number. And see, 50% didn't work for me there. All right, let's do another one. Let's do, so do you see why those are not mutually exclusive? They can happen at the same time. That's what you got to think about. They can happen. They can happen. They're not mutually exclusive. All right, let's say I wanted the probability of a 10 or a red card. Again, they are not mutually exclusive. Okay, why? Well, because I can get a 10. Matter of fact, I can actually get 2 10s that are also red cards. See, so that's 10 and red. So 10 or red, that's not mutually exclusive. I can get a card that's a 10 and a card that's red at the same time. See, right there. Okay, so what we do is, this would be the probability of a 10 plus the probability of a red minus the probability of a 10 that's red. or a red 10, if you will. Okay, so how many 10s are there? Well, there's 4 out of 52. How many red cards? Again, guys, you have this. For those of you that don't know, look. Reds, I even tell you, there's 13 in each suit. So there's 13 diamonds, 13 hearts. Those are the red cards. So there's 26 of them. Okay, plus 26 out of 52 minus the 2 red 10s. Do the math. Let's see, that's 30. That's 28 out of 52. Divide by 4 is 7/13, I believe. Okay, so the probability that when I pick a card at random that I'll get a 10 or a red card is 7/13. Okay, not mutually exclusive. Okay, these guys are not mutually exclusive. Now, you could actually take something we've done before, all right, and you could do actually like a little, I don't know if you want to see this or not, but I'm going to do it anyways. Yeah, I don't think I want to do this. Yeah, I will. You can handle it. You guys can handle it. All right. We did the Venn diagrams in the last lesson. So here's kind of like what it would look like. Let's say this were my 10s. This were my red cards. Okay. So what I would have my 10 of spades, 10 of clubs. Then in here I would have my 10 of hearts and 10 of diamonds. And then here I would have the remainder of my red cards, which would be 12 other hearts and 12 other diamonds. Okay, so the probability that I will get a red or a 10, you can see where this is the and part. That's the overlapping part. Okay, that's the overlapping part. So there's, actually this is a little misleading. That's 12 hearts. That's 12 other diamonds. If I could spell diamonds. Woo. You're bad, Scott. Okay, so that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, Jack, Queen, King. And then, but this is just the 10 of spades. 10 of spades. 10 of clubs. So that's just one card each. So 1, 2, 3, 4. Then there's actually 12 hearts, 12 diamonds. Okay, so don't get confused on that. But I should have written them all out, but there wouldn't have been enough space. All right, so that's what you do for not mutually exclusive. Now, real quick. I know you've heard of somebody saying, oh, what are the odds of that happening? Well, odds are not quite the same thing as probability. Okay? Probability, basically, is this. Probability is my favorable outcomes over the total. Okay? The odds are just a bit different. The odds are favorable over not favorable. And I'll give you a quick little example of those two. All right. So for instance, what if I said I wanted a probability that if I draw a card, it will be a king? Well, how many favorable outcomes are there for me? Well, there's 4 kings. So that would be 4 out of a total of 52 outcomes, which would be 1/13. So the probability that I get a king is 1/13, 1 to 13 or whatever. The odds, I don't know what the symbol is. The odd of drawing a king, though, the odds, favorable still 4. But not favorable, well, 52 is the total number. The ones that are not favorable, well, if there's 4 that I want out of the 52, that means there's 48 that I don't want. So the odds would be 1 to 12 of me getting a king. So probability, odds. Probability, favorable over total. odds favorable over not favorable. Okay? All right. So, gave you practice. It was page, I believe, P15, 1 through 10. Guys, keep up on the graded assignments. Still about 10 to 15 of you that are falling behind. And if you're behind, you're not going to be watching this till later. So, hope you're getting on the campus. I hope you guys are reading the announcements, reading the things. Okie dokie. I think that's all for this lesson. Good luck, guys. You can, again, text me, call me, text me, say I need extra help. Let's do a WebEx. It's literally as easy as you clicking on the link that I've sent you various times. I could send it to you again. Probably got about 5 weeks left, guys. Some of you are getting way behind. Let's crank it up. I'm here to help. Till the next time. Bye-bye.